So for our first examples, we are going to look at drawing a card from a standard deck and finding the probability that the card is a 4 or an ace, and then the probability that the card is an ace or a heart. So for this, we want to look at first the probability of 4 or ace, which I'm just going to denote A. And what we should understand here is that if we're talking about drawing from a standard deck like this, well, there's not a great deal to what we're looking at, because, thankfully, when you're drawing these cards, you can get a 4, and there's 4 of these, or you can get an ace, and there's also 4 of these, but there's no card in here that is simultaneously both an ace and a 4. So, importantly for us, that means that what we're looking for here is a probability using addition, using OR, where the events are disjoint. So that's just the probability of a 4 plus the probability of an ace. And I'll say that as we're getting more comfortable with this, you should get used to the idea that when we see the word OR, think in terms of addition, and if we see the word AND, think in terms of multiplication. For this, not so hard though, we have 4 4s out of 52, as well as 4 aces out of 52, for a total of 8 out of 52, or if you prefer to simplify, 2 out of 13, which should make sense because you can think about that as being the ace of a particular suit or the 4 of that suit that goes with it. On the other hand, for that second case, where we want the probability of an ace or a heart, what we should understand here is that in our deck, we've got the probability of getting aces, it's pretty straightforward, and we've got the probability of getting hearts, that's also pretty straightforward. But thinking about our cards, yes, we've got aces that are just aces, and in here we've got hearts that are just hearts for our one drawing, but the problem arises when you have to remember, we also have the ace of hearts in here to consider. So, when we're talking about this, when we're talking about these probabilities, these will not be disjoint events, because there is explicitly one case where you can get both an ace and a heart, the ace of hearts. So, we have to remove that. Remove that probability of ace and heart, which I will just denote ace of hearts. In this case, it has a specific name. So, when we get our probability, we have our 4 aces plus our 13 hearts, and we must bear in mind that in here, we've counted the ace of hearts, and in there, we've counted the ace of hearts again. So we've got to remove 1 ace of hearts to make sure that we don't have too much. So just 1 out of 52, which means our total, in this case, will be 17 minus 1 over 52, or 16 out of 52, which simplifies down to 4 out of 13, and in this case, there are logical arguments where that 4 out of 13 comes from, but they're not quite as clear as the other example. But anyway, that's what we'll be doing more of here. Get some more practice with this stuff. We're going to be looking at cases that, instead of having just these drawn out things, we'll have tables of information instead.